All right, Math 8 students, here we go. This is the guided practice for 12.2. We'll walk through these questions if you need a little extra assistance on kind of seeing how they are solved or just want to watch and make sure that you're doing all your steps correctly. Okay, taking a look at number 1. Lashandra used grid paper to construct the triangle shown. What are the lengths of the sides of Lashandra's triangle? Blank units, blank units, blank units, blank units. Let's go ahead and make this A, B, and C, and we'll do A first, so that is how many units? 1, 2, 3, 4, 5, 6. 6 units. Next one would be 1, 2, 3, 4, 5, 6, 7, 8. 8 units. And that last one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. Okay, now we're going to use the converse of the Pythagorean theorem to determine whether the triangle is a right triangle, meaning we need to find out if it is equal, right? If these side lengths squared of the legs are equal to the hypotenuse squared. So we're going to plug those values in. 6 squared plus 8 squared, maybe. Does it equal 10 squared? We'll find out. 6 squared is, 6 times 6 is 36. 8 squared, 8 times 8 is 64. And 10 squared is 10 times 10, which is 100. 30 plus 6 plus 64 is 100. So it is, in fact, equal. So that is a right triangle. So that means that Lashandra constructed, the triangle she constructed, is a right triangle. So since we proved the converse to be true, a squared plus b squared is equal to c squared, then we know that it's a right triangle. Number 2. A triangle has side lengths. Let's go ahead and move this up a little bit. A triangle has side lengths 9 centimeters, 12 centimeters, and 16 centimeters. Tell whether the triangle is a right triangle. So we're going to go ahead and plug those numbers in. Let A equal 9, B equal 12, and C equal 16. These first two are, of course, interchangeable. The legs are interchangeable, but C has to be that longest length. Now we're going to plug that into our Pythagorean theorem and determine if the converse is true. So determine if a squared plus b squared is, in fact, equal to c squared. So plugging those values in, 9 squared plus 12 squared may be equal to 16 squared. Let's find out. 9 squared, 9 times 9 is 81. 12 squared, 12 times 12 is 144. And 16 squared, 16 times 16 is 256. Let's go ahead, add 144 and 81, and we get 225. Bring this number down, 256, and they are in fact not equal. These are not equal, right? So since they are not equal, since a squared plus b squared is not equal to c squared, then we do not have a right triangle. So by the converse of the Pythagorean theorem, the triangle is not a right triangle. Moving right along into number 3. The marketing team at a new electronics company is designing a logo that contains a circle and a triangle. On one design, the triangle's side lengths are 2.5 inches, 6 inches, and 6.5 inches. Is the triangle a right triangle? So what we need from this is those side lengths. We're going to plug those into our Pythagorean theorem, and I'm going to do this work up here. So I'm going to use my 2.5 as A. So 2.5 squared plus 6 squared is maybe equal to 6.5 squared. So I'm going to go ahead and solve that to find out what 2.5 squared is. 2.5 times 2.5 is 6.25. Plus 6 squared, which is 6 times 6, which is 36. So when I add those up, I get 36 plus 6.25, and I get 42.25. And we're going to see if that is equal to 6.5 squared. which is 6.5 times 6.5, and that equals 42.25. So these are, in fact, oops, I wrote that wrong. Let's try again. 42.25. Sorry, that went off the screen there. So these are, in fact, equal. So it does make a right triangle. So yes, it is a right triangle. And that is because 2.5 squared plus 6 squared does equal 6.5 squared. And I'm just going to go ahead and just put 4.25. Oops, not 4.25. 42.25 does equal 42.25. So that's my explanation there. And then my last question that I have is my essential question check-in. And it's asking us, how can we use the converse of the Pythagorean theorem to tell if the triangle is a right triangle? The converse meaning you're just trying to prove that a squared plus b squared does or does not equal c squared. So how can you use the converse of the Pythagorean theorem to tell if the triangle is a right triangle? Well, you are going to test the side lengths, right, of a squared plus b squared to see if it's equal to c squared, right? So test side lengths, a squared plus b squared, to determine if it's equal to c squared. And then just remember using the longest length for c. The longest given length. If it's true, it is a right triangle. It is a right triangle. And then just going back to some of the earlier stuff that we looked at, we also know that if a squared plus b squared is greater than c squared, it's going to be acute if c squared is smaller. And if a squared plus b squared is less than c squared, so if c squared is the bigger one, that's going to be an obtuse triangle. So if it's equal, it's right. A squared plus b squared is equal to c squared. That's right. Okay, getting a little... so that's just summarizing some of the stuff we did earlier this week, right? Okay, so that is it for the guided practice. If you have questions, please make sure you're writing them down. I know the writing is a little bit sloppy, still getting used to some of our new tech. So if you got questions, please make sure you ask, write them down, bring them in, talk about them. That's so important to making sure you're understanding what you need to do. All right, I'll see you on the flip side.